Now sir, we can use transistor for the different purposes depending on simply the configuration of the transistor and biasing of the transistor. First one, we are going to use transistor as a switch. So we can write here transistor as a switch. Suppose we take NPN transistor here like this, and this NPN transistor, this is here the direction of current, this side is common here, this is NPN, and there is a resistance that is called RB, and then we can write here the biasing of this. This is your VBB and this is forward biasing. Then we can take here this side, this is here RC, and then we can write here this is NPN reverse biasing with the positive, and this is called VCC. Now here the base emitter voltage here, that is here we can take as VI and here we can take as VO, that is called output voltage. So this circuit we use basically for the transistor characteristics. Now if you use this input part here and this output circuit here and apply Kirchhoff's law in both the cases, we will be getting here VBB is equal to VBE plus IB RB. This is IB is the base current which is going to this side, and here IC is here the collector current. And we can get VCE, that is a collector emitter voltage, is equal to VCC minus ICRC. So this can be written equal to VI and this can be written equal to VO. So according to Kirchhoff's law in this loop and this loop, we have got these two equations. Now look at its working here. This we are using a silicon transistor, and in silicon transistor if we take input voltage less than 0.6 volt. So first thing is here, if I am taking, first point is here, if Vi is less than 0.6 volt, this is for silicon transistor I am talking about, and we have done here the input characteristics of the transistor characteristics. Here below the 0.6 volt transistor does not conduct. So if the input voltage is 0.6 volt, then the transistor does not conduct. It means IB is here in this case 0. If IB is 0, there is no base emitter current, I is 0, as a result IC is 0. If IC is 0, then output we are getting maximum and we will be getting VO is equal to here VCC. So output is maximum. Now if you keep on increasing here, the VI, if you are increasing VI more than 0.6 volt, you will find there is an increase in the IB. When IB increases, I increases here. So because the forward biasing of the input side, I increases, as a result IC increases. If IC is increasing, then the output keeps on decreasing. But when you keep on increasing the input voltage, you will find there is a decrease in the output voltage linearly. So for certain range it decreases here linearly, and after that if you keep on increasing input voltage, you will find there is a more and more increase in I and IC, but output voltage keeps on decreasing, but it will never be 0. So see here the output voltage after some time around when you are taking the very high voltage here, the output voltage, input voltage, you will be getting here the output voltage become to the certain value and it becomes almost constant. That is called saturation region of the transistor. The graph we can get for these in all the three cases here, the nature of the graph, that is a transfer characteristics of the transistor, is actually in this way. Here you can take Vi and here you can take Vo, and the graph is something like that in this way. Here this one is called output is maximum, so this one is called cut-off state, cut-off region of the transistor. The transistor does not conduct in this case. And now this one is the linear here, that is called active region of the transistor. And here where the output is almost constant, whatever is the value of the input, this one is called saturation region. So working of the transistor is here actually divided into three parts. One is a cut-off region, active region and saturation region. if you are using, if the transistor is not conducting, suppose, so that is a low voltage when the transistor is not conducting, we can say transistor is switched off. But when the voltage is enough high, but the transistor is conducting and output voltage is almost constant, we can say transistor is switched on. So, when you want to use the transistor as a switch, its working has to be in cutoff region to the saturation directly or saturation to cutoff. So, you have to decide or assign certain low voltage and high voltage for switching off and switching on the circuit. But you cannot use in active region as a transistor as a switch. So, whenever the transistor works in the active region, the transistor used as an amplifier. So, now let us see the working of the transistor as an amplifier.